Okay, so next up, let's take a look at escape sequences. So far, we've looked at literal data. We've seen how to use a constant string. You use double quotes for strings, and actually you're supposed to use single quotes for constant character, so that should be single quotes Z. And these are all examples of literal constants. That is, you basically literally type them into your program, so they're literal constants. You cannot assign values to, for example, a number like 2. You can't say 2 equals 5. So those are literal constants that you type in. So same idea with strings. You put them in double quotes. Those are literal constant strings. And we have the same idea in Java. Within these strings, we can embed escape sequences. These extend the normal character set. You put a backslash character just before a character, and you create what's called a special escape character. We've used this in Java. Backslash n is for a new line, and so on. Those kinds of things that we've seen before in Java. Okay, so here are some escape sequences. Backslash n we've used, it's the new line. Backslash r works differently on different operating systems. On Windows, we always use backslash n. On the Mac OS X machines, we use, or Macs in general, you tend to use backslash r. And on Linux, both of them are used. So it depends on the operating system. Backslash t is a tab, /a is a bell, usually works. And if you say backslash, what that says is it protects the backslash. And so it allows you to make a single backslash or inside double quotes. Let's take an example of this. Let me just pull up a program. Escape sequences. Whoops. Here it is. Okay. So I set up a simple program to test out some of these ideas. I print out escape sequences, then I say wait 2 seconds to see what backslash n does. So here what I wanted to do was I wanted to print out backslash n. In order to do that, I have to protect the backslash character. So that's why I need 2 double backslashes. If I omitted this first one, I would get a new line after what, and then does will show up on a new line. So I don't want that, so I protect the backslash n. So we've seen this kind of thing before. We'll get into more detailed explanation of what cout does, what this insertion operator does, and so on. It's pretty straightforward. Once you use it, you can see they're not that hard to use. You just have to remember to put them after the cout. And in some computers, you need to flush out what's in the string previously. Without a new line character, sometimes these things don't get printed. And so in this particular system, I don't need this, but in general, on some computers, you might actually need to flush so that this does show up. Okay, so I'm going to run this escape sequence. Run this as a local application. All right, wait 2 seconds. We got a new line. Wait 2 seconds. The /r on the Macs, it does the same thing as a new line. The /t gives us a tab. So notice this space. This is one tab character. And the backslash a is supposed to give us a bell. Actually, I didn't hear it. I didn't turn up the volume. But you might want to try it out. But try the backslash a. So once again, we print out this message, we flush it so that the user can see it, we wait for 2 seconds. This is a simple function that just does nothing for however many seconds. And then we print out whatever character, in this case the bell character, in this case the tab character, in this case the carriage return, which on the Macs does the same thing as the new line. So try these out. These are all good examples of escape characters to try out. I'm guessing that most of you have seen all of this it behaves pretty much the same in Java. There are other escape characters that we're not going to look at. Single quotes just protects a single quote character so that you can actually use this instead of, so you can actually see the single quote character. Just like if you wanted to have double quotes inside a string, you have to protect the double quote. So to print out a string, you need a double quote. If you want to print out a single double quote, you want to have something. You can do something like have a double quote followed by a backslash double quote, ending with a double quote that finishes the string. So try it out. If you take it on as a challenge, try printing a single double quote, and you'll see that you need this. Then there are vertical tabs, just like /t is a horizontal tab. You can backspace over what you already wrote. Things like that. Okay, let's move on to constants. Typically, you want to always name your constant. That's usually a coding convention. You don't want to have numbers in the middle of a program, like 24. The problem is that it might be perfectly fine, but might not tell the reader anything about what this number represents. So there might be some important meanings to some of your literal constants, and someone who's reading your program may not be able to figure it out. That's why you always want to say const int like this. It's just like in Java we have final, in C++ we use const. That's basically the only difference, really. We say const int, and then almost always the convention is that just like in Java, you're supposed to have constants in all uppercase. And then give it the value. Okay, so literal constants like 24 are okay, but they don't give the reader any idea of what this 24 represents sometimes. And so it's a much better idea to actually name the constants. And you want to use a meaningful name to represent this data. So this is called a declared constant or a named constant. And now whenever we need to use 24, instead of just typing in the number, we use this number of students, and your program is a lot easier to read. Also, if you need to use it in a bunch of places, like if you have 24s all over your program and then you figure out that you need to change it for whatever reason, instead of changing all of those occurrences of 24, you can change one value and they're all fixed. Okay, so we have a simple example. This is straight from the book. This is display 1.4, and it uses the const double rate. And I have a simple program that demonstrates this. Named constant. Okay, so here it is. I have a const double rate is equal to 7. This is supposed to represent 7%, so maybe I should have called it interest rate. That would be probably more descriptive and probably better. So in Eclipse, you can right click and say refactor, rename, and I can do something like this, interest, make it more descriptive. And notice that it changed everywhere. If you had the 7 here and the 7 here, it just gets kind of messy. So it's much a better idea to actually name your constant, and that way if you need to ever change the interest rate, you change it in one place instead of all the places it's used. Okay, so I print out a message saying enter the amount of your deposit, and I use a $sign, and that way when the user enters a deposit, it'll show up right next to the $sign. Notice I don't give this a new line so that the user gets to enter some input right at the same line. So let's try this out. I'll run this as a local C++ application, and it recompiled. And so now if I go in here, because I didn't give it a new line, the user gets to enter something right next to the dollar sign. Sort of makes sense for the user. I'm going to say 100. And what will happen is that will go into this double variable called deposit. So cin does the opposite of cout. It gets some input from the console, and the extraction operator, which is what this double greater than sign will put input into this variable. And you can have these sort of daisy chained or streamed. You can have one after another if you want. In this case, we just need one number. When I hit enter, and then it'll all, so right now just typing in 1 doesn't put a 1 into deposit, or a 0 doesn't put 1 0. You have to hit enter. And as soon as I do that, I do this little computation, compute out the new balance, and I print out this message. So you can see that you can use multiple insertion operators, just like we did in the last program. So I print out at an annual percent rate of 7%. Notice I can use the percent symbol. And then I put a dollar sign to format it nicely, put in the deposit, which is 100, will become a new balance of 107. So check this out. Make sure all of these statements make sense to you. Looking at how to format things when you use cout, things like that. So these are all nice, simple C++ programs. Shows you some of the basic or simplest differences between Java and C++. All right. Next up, we'll take a look at arithmetic precision. So that'll be in the next video.